the last 4 years, we have, as a Blueprint, been characterizing all the cell types, or almost all the ones that we were intending to do.
We've been studying variation on the genetic sequence between individuals, and we've been able to link in the last 12 years hundreds of different disease states.
So the power of Blueprint is that it creates a map, and a map tells you where you are. We can now do focused epigenome mapping on a specific disease mechanism, but we always know where we are in the broader scheme of things because we have the map.
We thought when we started, cancer is essentially a genetic disease. What we learned during the process of a project was that single or few genetic hits can have a kind of avalanche effect. So they can reprogram the whole cell.
So what we do is to try and understand what happens between the DNA variation and the change in protein. What are the steps in between?
Before we thought that every tissue had a different epigenome and even every cell type, but even one cell type during the entire maturation program shows massive epigenetic changes. And we have seen that each particular maturation stage maintains an epigenetic memory of all the past activity states, so that the final destiny of the B cell, which is a plasma cell or a memory cell, contains in its epigenome all the history. It's a kind of, the epigenome is like a kind of storyteller. It's telling us, what has happened during the entire process. And the final cell contains the whole book, the whole history,
We see a major transformation of medicine from an art into a data science. When we think of big data medicine, it's really the synergy of the advantages of the traditional physician-centered medical system and the computer-based system.
One of the important things about Blueprint, though, is it's very complex data. It's not just a lot of data, but there are a lot of ways that you can slice it up, lots of different cell types, lots of different assays. So it's big data, but it's also complicated.
We have done a lot of research in the last 4 or 5 years and invested enormous amount of efforts into it. Now we think we have bases on which we can develop new drugs, new medicine.
We want to generate outputs that are not just going to sit there in journals, but we want those outputs to have an impact on society and mankind. And so, what we're doing is we're working in close partnership with industry. It's important for us to understand what their challenges are, what their technical gaps are, what are they looking for, what sorts of medicines are they looking for, etc.
I've just asked one of the private companies, what was your sort of benefit in working for Blueprint? And they said it was access to data and access to collaboration.
This is a huge endeavor. So it needs quite a financial support, and it needs also specialists, and you won't find specialists in one country alone.
It's been a really exciting project because it's brought together scientists from very different disciplines.
I've made connections with a lot of people from Spain, from Austria, from the Netherlands, from all sorts of different places. And this is a great thing for me because I can go on and carry on doing more science and better science with those connections.
It's remarkable how far the group has come, and it looks very promising. I think as a member of the advisory board, we're very excited about the progress that has been made.
The results that we have generated up to this point, so we're end of year 4, are far beyond what we had planned. We probably have doubled from what we thought we would be able to achieve.
But the overall goal, obviously, to cure patients, to have a better treatment. Therefore, Blueprint is a kind of the basis for further research.
We are now in the final year of Blueprint, which is, for me, the most exciting of it all. because we will finally see the seeds of what scientists have been planting.
It's obvious that none of the groups will just stop doing these things. We will all use the blueprint data to build on the top of that and continue with new international projects, with new collaborations.
You don't want to spend 5 years bringing all of these people together and get them working well together with a goal and then suddenly to dissipate, etc. It would be nice somehow to sort of build on this momentum and, if you like, do blueprint phase 2.
So there will be a new blueprint, maybe not the name, under the name blueprint, addressing some of the fine detail that are impossible with today's technologies, but we are generating the enabling tools to do so.
So my dream for the next years is that we are setting the stage to come closer to those questions and to better understand what we call nowadays the system in which this epigenetics really works, the system of our body, and this is my future dream.